Adding and subtracting radicals. Like radicals are radicals with the same index and the same radicand. Same index and same radicand. So make sure you remember same index and same radicand. Like radicals can also be combined with addition or subtraction by using the distributive property. Now, if I were to ask you something like, what is 2x plus 5x? You would tell me, hopefully, that the answer would be 7x. So, like terms is what we're focusing on here. When you add and subtract terms, you have to have like terms, right? The same variable and the same exponent. Well, this rule applies with your radicals. With the radicals, you have to have the same radical and the same index. So notice I have 2 square roots of 3 plus 5 square roots of 3 is going to give me 7 square roots of 3. So it's the exact same concept as adding and subtracting like radicals, or like terms. You have to have like radicals as well. So for example, add or subtract as indicated. If I have 1 square root of 3 plus 7 square roots of 3, right? I have 1. If I don't see a coefficient, it's understood to be 1, because you know if I had x plus 7x, you would know that I would have 8x. Same thing with the radicals. If you don't see a coefficient, it's understood to be 1. So 1 square root of 3 plus 7 square roots of 3 is going to be 8 square roots of 3. So here, 10 square roots of 2 minus 4 square roots of 2 is going to give you 6 square roots of 2. And again, these are not like radicals. I have 1 square root of 5 plus 1 square root of 3. And since they're not like radicals, you cannot add those together. So you can't simplify that, because the radicands are different. The indices are the same. You're doing square roots here, but your radicands are not the same. So remember, you have to have the same index and the same radicand. So here, I have the same radicand, but look at your indices. My index here is 3 and my index here is 2. So since the indices are different, I can't simplify those either. Okay, so you have to have the same index and the same radical in order to put these together. Alright, so let's try this. Notice I have the same index, but I do not have the same radicand. So let's see if we have a perfect square that will go into this 27. So in other words, let's break this down into its perfect square factors. I know that the biggest perfect square that will go into 27 is 9 times 3. And so plus, same thing with 75. I know that that will be 25 times 3. The biggest perfect square that will go into 75 is going to be 25. So now let's break that down. The square root of 9 is going to be 3. Can't do anything with the square root of 3. Plus the square root of 25 is going to be 5. Can't do anything with the square root of 3. So now I have like radicals and I can simplify. So 3 square roots of 3 plus 5 square roots of 3 is going to give me a total of 8 square roots of 3. Alright, so let's try this one. I don't have like radicals, so I cannot subtract them. So pay attention to the sign in the middle. That tells you what you're doing. So I'm subtracting here. In order to subtract, I have to have like radicals. Well, right now, they're not, because I have a square root of 20 and a square root of 45. So then the next step is to look to see if these will simplify individually. In other words, is there a perfect square that'll go into 20? And the answer is yes. So I have 3 times the square root of 4 times the square root of 5 minus 7 times the square root of 9 times the square root of 5. So let's simplify farther. So we have 3 times the square root of 4 is going to be 2. Can't do anything with the square root of 5, so it stays under. Minus 7 times the square root of 9 is going to be 3. Can't do anything with the square root of 5, so it stays under. Multiply out, so we have 3 times 2 is going to be 6 square roots of 5 minus 21 square roots of 5. And then when we subtract that, we're going to get, I think 15. 6 minus 21? Yeah. So you have negative 15 square roots of 5. Alright, simplify the radical expression. So let's keep going with what we're doing. So we have minus, or the opposite, of square root of 75 plus the square root of 12 minus 3 square roots of 3. None of these are like radicals, so I can't just add and subtract. So what I need to do is I need to try to simplify these. So let's think. The biggest perfect square that'll go into 75 is 25 times 3, square root of 3, plus for 12 I have a 4 times 3 minus 3 root 3. Alright, let's continue simplifying. So we're going to take the opposite of the square root of 25, which is going to be 5, times the square root of 3, plus the square root of 4 is 2 square roots of 3, minus, and 3 square roots of 3 will not break down. Now look at what I have. I have square root of 3, square root of 3, square root of 3, so I'm ready to put those together. So negative 5 plus 2 is going to be negative 3, and then another negative 3 is going to be negative 6 square roots of 3. So what about variables? Simplifying the following radical expression, assume that variables represent positive real numbers. That just means we can't have negatives, and we know that. So look under here. I have the same index. I'm doing square roots, so that's okay, but my radicals, or my radicands rather, are not the same. So let's see if we can get them to be the same. So I have 3, and then times 9 will go into 45, so I have the square root of 9 times 9 times 5, and then of course I have the square root of x to the third, plus x, and square root of 5x will not break down, so that's going to stay as is. Okay, so I know 3 will break down. Square root of 9 is going to be 3. Can't do anything with the square root of 5. Now, x to the third, remember we're dividing 2 into 3, and we can go off to the side. 2 will go into 3 one time with 1 left over. So that's going to turn into x square root of x. Remember, we have 1 that comes out and 1x that stays under, plus x square root of 5x. Alright, so this one on the left, let's see if we can fix all this. We're going to have 3 times 3 times x, which is going to give me 9x, and then I have square root of 5 times square root of x is the square root of 5x. So we're multiplying all the whole numbers or coefficients, and then we're multiplying all the radicals, plus x square roots of 5x. So now I have like radicals, so I can add 9x plus 1x is going to give me 10x square root 5x. So you may want to go back through that problem again because that one's a little bit tricky. Alright, so this time we're dealing with our cubes. So when we have cube roots, we have to look at that cube list, remember. So what is a perfect cube that will go into 64? So the cube root of 64 is straight up 4. Plus, I don't think there's a perfect cube that'll go into 18 because the only thing I can think of is 2 and 7, and neither of those are perfect cubes. So that's not going to be able to break down. And then we have minus 9. So now, to simplify this, all I'm going to do is I'm going to put my whole numbers together. So 4 and negative 9. Remember, sign in front of the number goes with that number. So we have 4 and negative 9, which is going to be negative 5. And we're adding, we're not multiplying, plus the cube root of 14. So you have negative 5 plus the cube root of 14. So be very careful with that when you're multiplying versus adding. Again, pay attention to those signs. So again, notice here, I'm multiplying all of these, but I'm adding when I get down here. So don't lose your inventory. It's very important. And then here. So here, the cube root of 64 is 4. I can't do the cube root of 14, and then I just have 9. So I'm combining 4 and negative 9 to get negative 5, but I am adding here a cube root of 14. So be careful that you do not have 5 cube roots of 14, which is what some people will typically write.